All right, are we on? Yep. Hello, Calc. You're watching this video after Friday's class, which was the 6th. So the 6th, the 7th, or the 8th. We're reviewing and we're finding the equation of a line tangent to the graph of this, y equals 2x plus 5 over x squared minus 3. So this is an oldie but goodie, and we're going to remember when we're asked to find the equation, the tangent line is straight. So I don't know what the graph looks like. Say it looks like that. I'm pretty sure it doesn't. But at the point that we're interested in, I'm erased that. We're finding the graph, the equation of the line tangent to the graph of that equation at x equals 1. So you have to know what x value. So you're going to come in and find your x value at 1. So say the graph hits, the value 1 will hit the graph right there. We would want the equation of the tangent line. So it's a straight line, so our y equals mx plus b is an old friend that will come out and help us with the equation of any straight line. So y equals mx plus b will get us started. We need to go and find m. So let's do the derivative of this function, evaluate it at 1, and that will be our value for m. So allow me to do the work here, and I'll erase it when I get it and put the value in for m. So if this is the function, the derivative is y equals the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Alright, cleaning it up on the top, I get 2x squared minus 6. This negative sign will go distribute through. 4x squared minus 10x all over x squared minus 3 squared. Alright, 2x squared minus 4x squared is a minus 2x squared. So we have a minus 2x squared, a minus 6, and a minus 10x. And we are going to evaluate all that at a 1. So putting in a 1, I get minus 2 times 1 squared minus 6 minus 10 times 1 over 1 squared minus 3 quantity squared. So on the top, I'm going to get a minus 2, a minus 6, and a minus 10. So that takes me to minus 18. On the bottom, I get a 1 minus 3 is a minus 2 squared is a 4. Reduced to minus 9 halves. So all that work I'm going to erase. I found the derivative. So if you need it, pause and use it. But I'm going to erase that. And save the number 9 halves, negative. Alright, I'm going to put that in my function for m. Alright, now I have to find my b. So where do I go to do that? And it turns out that I'm going to put in, just for a second, a value for x equals 1. And I have to go somewhere to find the corresponding value for y. And that is in this original function. So if I put a 1 there and a 1 there, what does y become? It looks like it is 7 over minus 2. So is that correct? Is it 7? 1, it's 2 plus 5. So yes, it is. My y equals, I'm sorry, I'm pausing here because I was looking at my work earlier. And, oh, I know. So writing it out, I can't seem to do anything in my head. 2 times 1 plus 5, that is the 7. I was getting negative on my paper, and there for a minute I couldn't see where from, and that is from the denominator. So we have minus 7 over 2. So that's the x value when y is 1. So we're going to plug that in our equation. The y value is minus 7/2, and the slope is minus 2 9/2. X, just for a moment, is 1. Solve that so we can solve for b. Then we'll go back and put x and y back in our equation once we know b. So, moving the 9/2 over, negative 7/2 plus 9/2 gives me 2/2, which is a 1. So my b is 1. So I'm just going to go up to this step and erase the b and put in the 1. So you have observed me find the equation that is tangent to this graph, and it's y equals negative 9/2 x plus 1. Alright, so let's go ahead and do another kind of problem that's closely related. And in my mind of minds, I can't remember doing these with you. So it's kind of hard to review something that I haven't ever done with you. Maybe I did, so if not, it's easy to learn. So find the equation of the line no longer tangent to the graph, but the word normal comes out. Find the equation of the line normal to the graph, and this time we'll do a different one. We'll do y equals 10x over x squared plus 1. Alright, and I want that condition to be at 2, 4. So find the equation of the line normal to the graph y equals 10x over x squared plus 1 at 2, 4. Alright, this one, I think it looks like this. It kind of is asymptotic, and then it goes like that. It's asymptotic again. And at 2, 4, 1, 2, this must be 2, 4. This would be the tangent line. If I can draw a straight line, tangent line. And the line normal means perpendicular. Do you remember in physics, force normal is always applied by like a surface on an object perpendicularly to, the force is perpendicular to the surface that is providing force normal. So the word normal simply means perpendicular. So find the equation of the line perpendicular to the tangent line at y equals 10x over x squared plus 1. So at 2, 4. So once again, we're going to start with y equals mx plus b. So let me know if we've done these before or not. I don't know why I can't remember doing those with you. So once again, I'm going to find the slope, even though that is not going to be the m that I'm going to use. I'm going to have to adjust that m because perpendicular lines, this will be the slope of the tangent line right here, but I want the perpendicular one. So the tangent, how do slopes relate of perpendicular lines? They are negative reciprocals of one another. So when I find the derivative of this and plug in the value x equals 2, I will get a number. I'm going to flip that on its head and take the opposite sign. That's called the negative reciprocal. Doesn't mean it's negative, it means it's the opposite of what the original number is. So I'll do my derivative work here again. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Clean it up, clean it up, clean it up. 10x squared plus 10 minus 20x squared over x squared plus 1 quantity squared. Alright, and on the top we have a minus 10x squared plus 10 over x squared plus 1 quantity squared, all evaluated at 2. So putting in a 2 in this expression, I get a minus 10 times 2 squared plus 10 over 2 squared plus 1 quantity squared. So we have a minus 40 and a positive 10. So that in the numerator, it looks like I'm getting a negative 30. Yeah. Let's see if I got that earlier. Yep, minus 30. It's been confirmed. Over 2 squared is 4 plus 1 is 5. Quantity squared is 25. So that reduces to minus 6 over 5. So I've got that number, which I was interested in getting, the derivative, minus 6 over 5. But I'm not going to use minus 6 over 5. Because that would be the slope of the tangent line. I'm interested in the slope of the line normal to the tangent line, so I'm going to use the negative reciprocal. The negative reciprocal of negative 6/5, negative 6/5, if that's still on the screen, we're going to use the opposite sign, positive 5 over 6. That's the negative reciprocal of negative 6/5. So now, similar to what we saw in the last example, we are going to find b by putting in a 2 for x, and they also gave us the y. We didn't have to go calculate it. One less thing. So this is going to be 5/3. So 4 is 12 over 3, and this is 5/3. So moving the 5/3 over, I get 7/3 equals b. So going up here, instead of b, I'm going to use 7/3. Let me check my work against my paper. And it does confirm. So that's the equation of the line normal. So get used to the word normal. It simply means perpendicular. All right. So that's the end of part 1. I am also going to do another section where I will review another concept. So hang on to your seats. I'll be right back.